So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So let's practice this a little bit. So look at example 1. What should I do first? Ashley? If we're starting out, I really like what you're saying. That's going to be step 2. But what should I do before I plug it in?
Figure out which ones go where.
Yeah, kind of. What I'm looking for there is, let's write out the formula. Okay, so d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Wow, that looks like garbage. And I'm done writing on the board. I remember why I don't use that. Alright, so here we go. So we got d is equal to, this is not going to be much better. x2 minus x1 squared plus y2 minus y1 squared. What is this legible with? Okay, so that's your first step. I don't want you guys to do that every single time. So you get this down, Courtney. Every single time. Write out the formula. Okay, and then Ashley, you said start substituting things in, right?
Yeah.
Okay. So what's my x2 value?
7.
12 or the 7? Which one is it, guys? Oh. Okay, how do I know which one's x1 and y1 and which one's x2 and y2? How do we actually figure that out?
So isn't it just like the like if you're defining the slope, like
Yeah.
like how you label it?
Think about your x1 and y1 is your first point, x2 and y2 is your second point. And so it really doesn't even matter which way you're going here, you're going to end up with the same value. But for some of you guys, it might help to actually go in and label those. Especially the first couple of times that you're doing this. Just to make sure you're getting all the points in the right spot. Alright, so we're going to continue on here. Alright, so now that I've got them labeled, what's my x2 value? 12. What's my x1?
3.
We're actually doing that today. Okay? Plus, what's my y2 value?
7.
Minus. Okay, so what's 12 minus 2?
10.
10. We're left with 10 squared. 7 minus 7? Alright, so what's 10 squared? 100. What's 0 squared? 0. So what's the square root of 100? And we're done. Last distance. Okay. Okay. Your next task is to attempt number 2 on your own. Number 2 on your own. Morgan, come on to the board. I want you to show us how to do number 2. You can use my little tablet if you want.
I didn't put it in.
You can scroll up here. And Morgan, while you're doing that, to add some extra stress to you, could you explain to us what you're doing on each set?
Okay, first I'm writing out the formula. squared. And then negative 3 squared. Is 9 plus 4. And then I add it and equals 15.
Very good. Alright, guys, what questions do we have on this? I think you guys made some very crucial mistakes along the way, right? We didn't all do the square root of 13. So what are some questions that Morgan did up here that you guys didn't quite have on your papers? Is there a step where you made a mistake? Sam?
So, like, I got it right, but, so like on example number 1, we had a perfect square, so we did it and we got 10.
Mhm.
But on this one, since it's not a perfect square, we leave it.
Leave it in radical form. Alright.
Okay.
And this is kind of the disconnect sometimes from math for real world. Okay. In our math classrooms, we like to leave things in simplified radical form. 25 over 4 is a perfectly acceptable answer. 25 over 4 is usually this classroom makes no sense. So you're usually going to go with 6 1/4. Okay. But in here, it's perfectly fine leaving it in that fractional form. We're going to leave it in simplified radical form. Okay. And later on today, we'll talk about how to actually simplify those radicals. And we'll probably actually talk about that next. That's actually really important. I actually do have a couple of edits I want to do to Morgan's work. We want to make sure that we're not being lazy students. I'm not saying Morgan's lazy, but this is what I call being a lazy student. We want to make sure you're keeping that radical the whole way. Okay. A lot of you guys, as we saw before, you're putting down 13. You're right. 9 plus 4 is 13. We got our 13. Problem is, the answer is not 13. It's the square root of 13. And it's really easy to lose that square root unless we're keeping it on every single step. And then this is another area right here of concern that I have right here, the negative 3 squared. How many of you guys typed that in your calculator? Negative 3 squared. Can we try that? Type it in, tell what you guys get. Go ahead, use on the big ones. Find the negative button and type it in.
I can't remember if it says error or if it's
Just do it and tell me what you guys come up with. Oh, no, hold on there. So you guys just told me negative 3 squared is negative 9?
it's not.
Is that what your calculator told you? Negative 3 squared is negative 9? Yeah, no? Negative 13 squared. Okay. So negative 3 squared is negative 9. And here's why. Remember, calculators are really dumb. They're like computers. They do exactly what they're told. When you use that negative button on the calculator, it's not like it's just throwing a negative out there. The way that the calculator interprets that is negative 1 times 3 squared. And if you follow order of operations, which one of those are you supposed to do first? According to PEMDAS, you have to do the exponent before the multiplication. So when you do the negative 3 squared, the calculator is going to square the 3 and then apply negative. So you get negative 9. And that throws off your answers. So anytime you're dealing with negatives, please make sure always put them in parentheses. If you don't put it in parentheses, your calculator is going to tell you the correct information. Alright, that's a major wonder there. Okay, now, how many guys hate doing negatives?
I hate it, but it's not my favorite.
Can you put it on the equation? Okay, let me ask you this. We just said right here, this is the way to type it in. Okay, what's negative 3 squared? Positive 9. Okay, if I square negative 3 times negative 3, I get positive 9, right? What's 3 times 3? So if I square a positive, or I square a negative, what's my result? Positive. I get the same result no matter what, right? So the best way to handle distance formula is to not ever deal with the negatives. Can you guys count?
Yeah.
I'm being very honest here. Can you count? Easiest way to do this, I'm going to erase all of Morgan's hard work out here. easiest way to do this problem is to avoid the negatives. Uh-oh, I just killed it. Okay, so distance formula is square root. Distance between my x's. Guys, how far apart is 6 and 3? Doesn't matter. Don't worry about negatives. How far apart are they?
3.
3 squared. How far is 4 and 6?
2.
2 squared. And we're done. Square root of 9 plus 4 is 13. Don't even have to deal with the negatives.
Will you repeat that for all of them?
I think you just
Every
said
single one of them.
You can do that for every single one?
Yes.
Do you want to repeat that?
Yes. Don't worry about negatives. Don't worry about what direction you're going. All you have to worry about is how far you're going. How far are you going to go from 6 to 3? 3. That's it. That's all you need to worry about. So you're going to square the 3. How far do you go from 4 to 6? 2, so you square the 2. Don't even have to worry about negatives.